Welcome to qnawire.
In this problem, we have been given that from a leveled ground, a shell is fired at an angle of 53 degrees with respect to the horizontal at a velocity of 30 meters per second. So here we need to determine the horizontal as well as the vertical components of the shell's velocity. So here we will just project the speed along the horizontal. So the speed projected along the horizontal will give the horizontal velocity, that's 30 times cos 53 degree. So when we take the value of cos 53 and multiply that with 30, we get the horizontal velocity as 18 meter per second. And similarly, we can get the vertical component of velocity as 30 times sine 53. So that will be 24 meter per second. And now we have to also figure out the total time this shell is in air. So basically we need to compute the time of flight. So that will be 2u sine theta over g, whereby u is 30 meter per second, and we multiply that with sine 53 and divide it by the acceleration due to gravity, which is 9.8 meter per second square approximately. So here, to figure out the total time that this is in air, we multiply sine 53 with 30 times 2 and we divide it with 9.8 to get the time as 4.9 seconds approximately. And now we have to also determine the maximum height reached by this shell which is fired. So the expression to get the maximum height, that is u square sine square theta by 2g. So we put the values here once again and get the maximum height as 30 square times sine square 53 degree divided by 2 times 9.81 approximately. So when we take the value of sine 53 and square that and multiply this with the square of 30 and divide it by 9.81 approximately, we get the maximum height as 58.5 meters. And now we have to also figure out the horizontal range, which indicates the maximum distance this shell is able to land with respect to its firing position. So again, we're going to make use of the expression of the range, that's u square sine 2 theta over g. So that is 30 square times sine of 2 into 53, that's 106 degree divided by 9.81. So when we take the value of sine 106 and multiply this with 30 square and divide it by 9.81, so we get the result here as 88.2 meters approximately. And finally we need to figure out the velocity components as well as the accelerations at the highest point. So acceleration at any point will be in the vertical direction, and that will be minus 9.81 meter per second square, because this is due to the gravitational force acting in the downward direction, and the horizontal acceleration will be 0 because there is no such force acting along the horizontal direction. Whereas if we talk about the velocity at the highest point along horizontal direction, the velocity will be constant, and that will be 18 meter per second because there is no acceleration along horizontal direction. But the velocity at the highest point in the vertical direction, that would be 0 because as the ball goes up, it stops at that point in terms of the vertical motion.